Hello, my name is Sarah Pate, and I would like to welcome you on behalf of the Washington Center for the Book, an affiliate of the Library of Congress Center for the Book, in a partnership between the Washington State Library and the Seattle Public Library. The Washington Center for the Book promotes literacy and a love of books, reading, and libraries. We celebrate Washington's robust literary heritage and shine a spotlight on the contribution of reading and libraries in strengthening communities and in fostering civic engagement. One of our projects is the Washington State Book Awards, and we are thrilled to present the fourth in a series of online events with our 2020 Washington State Book Award winners with you here tonight. We'd also like to thank our event partner for this event and for this entire series, the Washington Library Association. WLA's mission is to lead, advocate, educate, and connect, and you can learn more at WLA.org. Eric Sigliano is a journalist and author with a longtime interest in climate change, the Arctic, and the alarming intersection between the two. He has been a science writer at the University of Washington and a staff writer and editor at several newspapers and magazines, and has written for National Geographic, New Scientist, Discover, Harper's, and Technology Review. His work has won Livingston and American Association for the Advancement of Science Awards and has been included in Best American Science Writing. Winner of the 2020 Washington State Book Award for General Nonfiction, The Big Thaw, Ancient Carbon, Modern Science, and A Race to Save the World, offers readers a chance to meet a diverse team of scientists and students who have been studying the permafrost and what lies beneath. This vast store of ancient carbon, more than 4 times the quantity found in all of today's forests, is releasing carbon dioxide and methane as the permafrost thaws. The release of all this carbon would alter Earth's climate forever. Braving endless hordes of mosquitoes, quicksand, and extreme temperatures, researchers are racing against the clock to educate us all about the changes we must make in order to preserve Earth's carbon balance. This book includes stunning photographs by Chris Linder and was published by Braided River, the conservation imprint of Mountaineers Books. Eric Sigliano, welcome, and thank you so much for being with us here.
And thank you, everybody, for coming or tuning in. I'd like to talk about something really sexy tonight, something that in a core sample like this one being analyzed by a Siberian student researcher looks at best like stale chocolate ice cream, but whose fate will have a huge impact on the future of civilization, humankind, and this planet as we know and love it. I'm talking, of course, about permafrost. Dig into Arctic soils, as in this cave excavated to store research samples and food, and you find yourself in a world that's earth and ice at once. 4 years ago, when I set out with scientists at what was then called the Woods Hole Research Center to write a book about it, permafrost, like so much in the Arctic environment, was pretty strange, exotic stuff. Since then, we've seen massive wildfires in Siberia, methane bubbling out of frozen sediments under the Laptev Sea, and Alaskan villages collapsing as the ground beneath them thaws and shifts. The Arctic does not seem so far away now. Its climate is becoming more like ours and, ironically, pushing displaced icy air down south and Arctic weather with it. Here's why permafrost is important. It comprises about 1/4 of the northern hemisphere's land surface. It extends from the northern tip of Greenland, 420 miles from the North Pole, to the latitude of Cairo and Houston on the Tibetan Plateau. Much of this frozen ground is Arctic desert or buried under ice. But the share that's vegetated, taiga forest, treeless tundra, covers 12.4% of Earth's land. Tropical rainforests cover just 7%. That doesn't include vast tracts of submerged permafrost that got inundated at the end of the ice ages when the great glaciers retreated and sea levels rose 120 meters. Humans and animals have worked out ingenious strategies to survive in these harsh environments. But their ways of life are now threatened as the climate warms and those environments change. Over millions of years, a vast load of organic matter has piled up and been preserved from decay, including these roots of 20,000-year-old grasses. Siberian Yedoma, loess that's blown up from the fertile steppes to the south, can lie 30 meters deep. It contains 10 to 30 times as much carbon as ordinary deep mineral soils. Animal remains also last here, like these buried mammoth bones recently exposed along the Kolyma River. Permafrost is one of our biggest carbon savings banks and climate insurance policies. By best estimate, it contains, and for now confines, more carbon than all the accessible fossil fuel reserves, much more than the atmosphere, even though atmospheric concentrations have doubled during Homo sapiens' time on Earth, and about 3 times as much carbon as all the forests on Earth. The Arctic's frozen seabeds may contain as much carbon again. They've just started getting urgent attention since this book was written. The Permafrost Savings Bank was long thought to be stable and secure, unlike forests that can be cut and burned. The Arctic operated as a net carbon sink. Not anymore. It's commonly said that the Arctic is warming twice as fast as the rest of the planet, but over the last couple of years, it's warmed much faster. Last June, the thermometer topped 100 degrees Fahrenheit for the first time in Siberia, in the same general region where these photos were taken. As the soil thaws, it bends and buckles. Trees become drunken. Things like houses and riverbanks collapse. Permafrost isn't uniform, so it doesn't thaw uniformly. It's often shot through with ice wedges that melt away, dissolving that preserved organic matter, forming puddles, ponds, and lakes, conveying heat deeper down. The result can look like Seattle's Denny Hill regrade, except that now we're transforming the landscape on a global rather than urban scale, with greenhouse gas emissions rather than steam shovels and high-pressure hoses. Fire accelerates the process. You saw the news of the devastating wildfires sweeping through Siberia's taiga forests last summer. We'll see more, but fire just doesn't just burn the forests. It's also becoming more frequent and widespread on the tundra. In 2014, more acreage burned in Alaska's Yukon-Kuskokwim Delta than in all the preceding 75 years. Arctic fires don't just consume vegetation. They burn away the thick blanket of duff that insulates the ground below. Dark charred soils absorb more solar heat, accelerating the warming in one of a number of feedback loops at work in the Arctic. Darker leafed bushes replace lighter colored, burned away sedges and lichens, further reducing albedo and increasing heat absorption. When the ice melts and soils are exposed, microbes get to work digesting all that organic material. One big question is how much they will convert to carbon dioxide, which is bad enough, and how much to methane, which, as you know, is much worse. During its 9 years of molecular life, before it breaks down to form carbon dioxide and water, methane has about 100 times the heat trapping effect of CO2. Bacteria operating in the presence of air produce carbon dioxide. In anaerobic conditions, such as these underwater, they release methane. How much methane depends on a host of factors: chemical, geological, hydrological, and atmospheric, as well as biological. Scientists are scrambling to unravel them and get a better idea of what we face. We are, if you will pardon a pun on a subject like this, looking through a gas darkly. Among the scientists working to unlock this mystery are the student researchers of the Woods Hole, now Woodwell Climate Research Center's Polaris Project. Each summer, the center gathers a group of intrepid undergraduates from around the world, from China to Puerto Rico to Bakersfield and Baltimore, the year I met them, and help them design and conduct their own original research into the changes occurring in the Alaskan tundra. Polaris Project and this book both began with similar happenstances, both involving, let's move ahead one slide. Both involving this young woman, Anna Suslova, a member of Siberia's Evenki people. Here's how the book begins. Anya Suslova had just turned 14 when the strangers arrived. They were the first foreigners and the first scientists she had ever seen. Outsiders rarely came to Zygansk, a northern outpost on Siberia's Lena River that was downgraded from town to rural locality in 1805 and never regained its earlier status. They couldn't reach it by land in the summer, when the ground turned to marshy, tire-sucking muskeg, or by boat in the winter, when temperatures fell as low as 75 degrees below 0 Fahrenheit, and the Lena froze as hard as the unthawing soil that lay just a few feet below the taiga. In the warm months, Anna's father skippered a government navigation aid vessel, keeping the channels clear on the Arctic's second largest river. Anya rode along with him when she could. That summer, in 2003, a team of Russian and American scientists on a research expedition spanning the Alaskan, Canadian, and Siberian Arctic chartered the boat to take them to various sites on the Lena and its tributaries. There they gathered water samples, chemical evidence of the changes that the vast, little-studied Russian Arctic was undergoing, and in an age of global climate upheaval. One of the Americans was Max Holmes, a specialist in river chemistry from a research laboratory in Woods Hole, Massachusetts. Max noticed how Anya shadowed him and his colleagues, observing their curious research rituals. He began waving her over to help, and she held the bottles while he filled them. After a week, she'd learned all the procedures, Max told me with a laugh. If I skipped a step, she would correct me. To correct myself there. After 2 weeks, the researchers had to leave. They would not be able to return to the Lena, a costly, time-consuming trek from Moscow, let alone from Massachusetts, until the next year. But Max had a heap of unused sample bottles and a bright idea as to how they could still be useful. Listen, he said to Anya via translator, it's really expensive for us to come here, and it would be really helpful if you could continue gathering samples while we're gone. This was no big deal. Max didn't expect anything to come of it. But when he and his colleagues returned to Zygansk the next summer, they were amazed to discover that Anya had continued taking samples along the Lena every 2 weeks and storing them in a freezer usually dedicated to holding fish and moose meat. That got Max to thinking that perhaps young people could do more in the pursuit of science than they're usually given credit for, an idea that led to the Polaris Project. The experience led Anya to learn English, study at Yakutsk, and in Korea and India, get a master's degree in climate science, and wind up working as a research assistant at Woods Hole, where I met her. I would never have heard her story, but for another happenstance. At the culmination of that year's Polaris Project, the newly initiated Arctic scientists returned to Woods Hole with their data, samples, and ongoing experiments. They hunkered down to analyze them and write up their findings, draw their charts and graphs, and prepare to present them at the American Geophysical Union Conference. Afterward, they set out to unwind by walking down to the scenic peninsula a mile away, where Woods Hole and Cape Cod end in ocean. They invited me to come along, but I was hobbling around on crutches after breaking an ankle, which made it impossible for me to head out on the vegetative trampoline of the tundra with them. So I drove out, mea culpa, with Anna as guide, and we stationed ourselves along the path we thought they'd take. But they never showed up. As we waited, she told me how she'd met Max and what followed. And as she talked, the story that I'd been trying to find opened up, and the book started taking shape in my mind on its own, it seemed. In a nonfiction narrative, an article, or a novel or short story, the beginning asks the question that the rest works to answer, though by the end, you may discover it's a very different question than what you thought it was. And her story asks that question. And now to the end of the book and a more serious note. Megan Benke, one of the Polaris students, told me what the work means to her. What's happening in the tundra is objectively terrifying, the way all climate change is objectively terrifying, she said. It makes you feel powerless. But in research, I'm also trying to deal with an interesting problem. Curiosity makes it easier to not feel paralyzed and become a weeping heap on the floor. Getting to study the changes doesn't make them less frightening, but it helps me live with the fear. The students, in the words of Sue Natalie, Polaris' director, that was her on the left, are not beaten down. For them, they feel positive. For them, there are no limits. They bring the spirit to science and to changing the world and making things better. I look at them and think, you're convinced it can happen, I'm convinced it can happen. Most of us don't have the luxury of transmuting our anxiety and alarm into the curiosity that drives science. The prospect of upheaval in the basic systems that make our planet verdant, fruitful, extravagantly rich in life and variety, and very simply, habitable, is daunting at the least. Scientists warn not just of the dire effects to come if we don't wean ourselves off fossil fuels, but of the effects of greenhouse gases already pumped into the atmosphere, there to reside for years, hundreds, in some cases, thousands of years. As the oceanographer Burke Hales puts it, we've mailed ourselves a package and now we can't call it back. The recent election and new national administration have brought a bracing, if belated, surge of activity to prepare for that package's arrival and to try to stop sending more climate package bombs. But the political pendulum has swung before from attempts at action to performative pantomime to, over the past 4 years, outright opposition. And it will likely swing again. I'd like to read a bit from the book's conclusion, and very slightly amended, remembering that I wrote it nearly 3 years ago. Politicians speak piously of the need to address climate change, but nudge it down the list of policy priorities, below the hot button social issues that impassion various segments of their constituencies. Others still stonewall any talk of climate or brazenly deny any human impact on it. Meanwhile, gasoline is cheap and life goes on. Global warming, everybody got excited about that 20 years ago, so we must have fixed it. Or we don't need to fix it. Or we can't fix it, so why worry about it? Our brains are wired to deal with immediate, urgent threats, not long-term problems requiring comprehensive, cooperative action and short-term sacrifice for long-term gain. Faced with these prospects, it's easy to take refuge in despair, to think if the glaciers are melting and the coral reefs are dying, I just want to see them before they go. But as the journalist and indefatigable optimist of the post-war years, Norman Cousins, liked to say, nobody knows enough to be pessimistic. Cynicism, like so many drugs, provides temporary escape, but turns toxic and crippling. Human nature is more adaptable than the doomsayers and denialists suppose. That's the secret of Homo sapiens' runaway success, which has brought us to our current plight. Change is really slow until it's fast. Societies, as well as natural systems, reach tipping points. They can change direction and shed attitudes and policies that seemed implacably embedded in culture in a historical blink of an eye. Consider how quickly the isolationist United States and its similarly unprepared allies mobilized to defeat the Axis powers after getting caught flat-footed in 1939 and 41. Or how racial and gender equality came to be legally enshrined and widely, if incompletely, accepted in a matter of decades after centuries of discrimination and worse. The pendulum swung for marriage equality in just a few short years. Mass mobilization and systemic change ultimately depend on concerted, i.e. political action, but they well up first from the bottom, from millions of personal conversions, of examples set and persuasions achieved, ultimately coalescing in popular demand that politicians cannot ignore. The critical federal civil rights legislation of 1964 and 65 did not come from on high. It grew out of decades of advocacy and agitation, from lonely personal protests to mass marches and boycotts. As President Franklin D. Roosevelt is famously said to have told one of his advocates, "Okay, you've convinced me. Now go out there and bring pressure on me." Making carbon-sensible choices in our daily lives is the first step in stepping up. Beyond the intrinsic value of the action is the little nudge this adds toward moving society as a whole. Stepping up puts a face on change, proving that it is possible and that the world as we know it won't come to an end if we embrace it. Reducing one individual's greenhouse impact makes an infinitesimal difference on the global scale. 1 million or billion reductions start to add up. The example they set and the market changes they drive may matter even more. At the political level, those who understand climate change as an existential challenge to human and other life need to act, and especially to vote on that understanding. Gun rights and anti-abortion advocates have something to teach on this score, believe it or not. Their political influence derives not from their numbers, but from their fervor and focus. They demand not just lip service, but action. Candidates know they will lose votes if they cross them. By contrast, concern for the climate and support for environmental protection tend to be like delta floodwaters, broad but shallow. Both have grown in recent years, driven by dire storms, floods, and wildfires, and by the threat presented by the last administration. But Americans polled last year still placed environmental protection below terrorism, economic concerns, healthcare costs, and education on their list of priorities, and placed climate action much lower. And that was before police violence and the pandemic swamped other concerns. Advocates for action must show the great mass of lip service supporters that a rapidly heating climate will overturn every other aspect of life. That, as the great civil rights leader James Farmer said, if we do not save the environment, then whatever we do in civil rights will be of no meaning, because then we will have the equality of extinction. Thank you for listening, for reading, for caring,